This lesson deals with Supplemental Problem 9.1. You can find this problem in the ECE202 ebook in the Chapter 9 Supplemental Problems on page 1. Can you use step functions to write expressions for the following voltage and current waveforms? Let's take a look at the first waveform. What I've got here is 0, and then I've got a ramp that has a slope of 20 divided by 4, which would be 5. I'm going to create a ramp, call it V1 of t, which should be a slope of 5, times t, and then times u of t, so that when t is less than 0, our function is 0. So it's going to be increasing now with time, but now at this instant in time, in 4 seconds, I want to bring it back to 0. So this slope is still continuing, so I need to add a slope with the opposite sign to cancel that. Do a minus 5 times t. But let's start that slope, not here at 0, but let's start it at 4 seconds. In other words, we've got a line like this with a slope of minus 5t. But we're going to turn it on at 4 seconds. So at 4 seconds, then it'll reach a value that's exactly the negative of the value here, which was 20 volts. Add those two together now, we're going to get the ramp going up and then going back here, basically subtracting off this value from this, and then any increase here is offset by this decrease, and so we get back to 0. So we get this for V of t. Okay, let's add the two voltages. So I have 5t times u of t, and then a minus 5, and then a delayed step function by 4 seconds. So I have u of t minus 4. Pull out the 5t, and I've got u of t minus 4. For our next wave shape, we have a value that comes up, and then levels out and comes back down again. So again, we've got a ramp. We're going to go to 20 milliamps in 2 seconds. So the slope would then be rise over run. So it'd be 20 milli divided by 2, or 10 milli. So I'll do again a ramp times u of t. So it's 0 for t less than 0, and then increases with a slope of 10 milli times t. Can I need that to level out? The value that I've reached here at 2 seconds, which is 20 milliamps, I need to now create a ramp with the opposite slope, but just start it at that instant in time. And so with this ramp, I'll begin to increase, and I'll get to 20 milliamps at 2 seconds. And this will start, and then any increase will be offset by a decrease. So we're just going to level out, go straight across. Then at 7 seconds, we have to come down with this and drop 20 milliamps in 2 seconds. So again, I'll use a u of t, delayed by 7 seconds, and then multiply it by a ramp that's also delayed by 7 seconds. So minus 10 milli times t minus 7, and then u of t minus 7. So what that's going to do then is give me no value until I get to 7 seconds, and then my ramp will start, not going back here to the origin, but starting here and decreasing at the 10 milliamps per second. And bring my value up, level it out, and then begin to bring it back down again. Now what I want to do is stop the waveform here and be 0 amps after 9 seconds, and so I'm going to again put a ramp to offset this one. I'm going to start it at 9 seconds. Same slope, but opposite sign, so 10 milli. Delay it by 9 seconds, and then multiply it by u of t minus 9, so it's 0 prior to 9 seconds. Add those all together. I got this going up, leveling out, coming back down, and then leveling out again. That's the waveform we have up on top. You can add all of these currents and then get an overall expression. The magnitude of the slope is the same for all of our functions, and so let's pull that out in front. So I've got 10 milli, and then times t u of t, and then I have t minus 2 times u of t minus 2, that's my next term. And I got another minus sign with a t minus 7 times u of t minus 7. And then lastly, I've got 10 milli, pulling it out, I got t minus 9 times u of t minus 9. That would be my current then as a summation of terms using the step function. And this is Supplemental Problem 9.1.